So welcome everyone to Megawatt Innovations in Distributed Energy Resources. I am Alec Antczak. I am a Senior Solutions Architect at CLEAResult. And I'm here to talk about a couple things related to DERs today. First, I want to talk about the landscape around distributed energy resources as a hot topic in the industry. Then I'd like to offer up a framework through which to contextualize distributed resources. And then lastly, I'd like to talk about some of the opportunities and some of the best practices that are starting to emerge as DERs begin to proliferate on the grid. So a couple quick statistics here. By 2025, DOE is projecting that $380 billion will be invested in distributed resources on the grid writ large. In a similar period of time, they're expecting with the opening of DERs into wholesale markets as a result of the passage of FERC 2222, which I'll get into in a minute. They expect at least an additional $125 billion in DERs wholesale transactions to occur in that same time period. But of course, all of this is contingent on right sizing the resource needs. And so how exactly do you best do that? So I'm going to hit you with a shocker here. DERs is complicated. Seriously, though, you know, the integration of distributed resources requires a wide variety of expertise. You need rates and regulatory folks, you need your operations folks, you need your finance folks, you need third-party consultants and technology manufacturers. Effective distributed resource deployments will require input from all parts of a utility. And when it comes to customer program folks and EE and DR especially, I hear a lot of confusion and apprehension about, is there going to be competition within the resource stack between, you know, EE and other DERs, or are DERs going to mess up my customer programs, or worse, are they going to, you know, kill them off completely, or, you know, is uncoordinated or unmanaged proliferation of DERs, is that going to create reliability issues, or is it going to lead to negative rate impacts, or, you know, is it going to lead to the proverbial death spiral of the utility? And I think the answer to all of that is no. The silver lining in all of this, I think, is in the name itself and distributed, because these resources live on the distribution system, and a lot of them, most of them, I would say, are even potentially behind the meter. Customer program folks and utilities, but customer program folks in particular, are in a unique and I would say crucial position to be able to facilitate that deployment. In fact, I think if there's any takeaway from this talk that I would want people to get, it's that customer program folks within utilities are going to be integral to the successful deployment of distributed energy resources. So the framework that I want to offer you has a couple of components to it, but I think it's very helpful to use to contextualize DERs, as I said. And I think as you begin to explore different deployments and different configurations of resources on the grids that you manage or work with, this framework will be very helpful to figure out how to optimize them and plan for them accordingly. So the first component of this framework is the technologies themselves. Obviously, you need to understand what types of DERs are available. The grid architecture characteristics of these technologies are, you know, they're important to consider. Is the resource passive? Does it need to be actively managed? Does it have export capabilities? Is there a load management resource that needs to be considered? Is it locationally dependent? Can it be aggregated, controlled from elsewhere? And probably most importantly, what is the data like? Are there intellectual property concerns with integrating these resources? The list on the left here covers the physical technologies themselves by category and explains some of the key grid functionality that's important to consider as you think through that list of equipment and controls considerations. You know, I think there's also considerations for controls themselves. Can multiple technologies be managed? Can they be island on a microgrid, for example? Could dispersed resources be controlled centrally to create virtual power plants, et cetera, et cetera? The list goes on, but that chart on the left is very helpful in sort of putting the boundaries around that discussion. The next piece of the framework concerns planning. How well can you forecast distributed resources on the grid? Can you access the data? How good is it? How can you forecast adoption rates of different DERs and how, the different configurations that you might see through time? Under each one of those adoption curves, what does the time series power flow analysis look like? What is the telemetry requirements? What control and communication strategies do you need to observe and direct resources? What kind of market mechanisms are in place or might be needed to facilitate the appropriate deployment here? And what kind of revenue streams might be considered in running sort of the cost benefit of these different configurations. The chart on the left here shows the limits of observability versus the number of DERs data endpoints, and it overlays that with latency limits, market control types, and appropriate purposes for DERs data. I think some of this may be kind of intuitive if you've dealt with DERs. The more endpoints you have or the slower the update rate of the data that you're getting, the less precise control you have over said distributed resources. And I think it adds precision and it's helpful as a tool in noting that the better the control you have, it gives you context for what types of applications might be appropriate. So for example, if you have a microgrid with DERs on it and you've got blockchain pricing, for example, you need to have at least as good as hourly interval data, although preferably something like 15 or even 5-minute interval data if you were to have, the more discrete DERs points you'd have on that grid. So if you're dealing with thousands of potential points, then probably 5-minute interval data is appropriate for that type of application. And so the last piece of the framework is the grid architecture itself. I could talk about hosting, interconnection, and markets, but those aspects are largely going to be handled by regulatory agencies. That doesn't mean that utilities don't have a role to play in their development and ongoing review, but by and large, those rules are set sort of outside the boundaries of grid operations. And so the chart on the left here is the grid architecture framework itself. And this is sort of a roadmap that you can use to keep track of all the different components of technology planning and market mechanisms that I've already mentioned. The idea here is to create a current state model, and then as you run through other considerations in the framework, you can see how the needs in the grid architecture change, and that helps you plan for how you need to resource for those changes. I personally have used this model pretty extensively in demand-side management planning and IRP planning. And although DERs planning is still in a fairly nascent stage, with the added complexity and dynamics of what DERs bring to the grid, I've found that this framework and this grid architecture model is incredibly useful in helping to plan for those and integrate them into things like IRP planning. So lastly, I want to talk about some of the opportunities. And this is by no means an exhaustive list. I think, with the complexity and dynamics of DERs, this is an ever-changing landscape. But some highlights that I just want to mention. First, on the technology side, I think dispatchable DERs is a big opportunity. I think immediately of the Rev for New York distribution system platform. I think the Hawaii HECO's battery storage initiatives to help customers manage demand charges is also a great example. And they've created a market where they can also sell that capacity for up to an hour. Smart inverter technology, I think, is not necessarily that new. Although the applications, again, to minimize disturbance on both sides of the meter is something new. And now that's becoming sort of a mandatory component of all customer-sited solar installations in most parts of the country. And then lastly, I think the SEAM system, the System to Edge and Network Architecture Management System for inline power regulators, which is another way to stabilize voltage and prevent backfeed from solar panels, is a really fascinating piece of technology that's starting to see wide-scale deployment. On the planning side, I think improving forecasting is, there are a number of tools that are being deployed, which will make the ability to forecast all aspects of DER's configuration and deployment just are going to revolutionize that process. Comes to mind, there are tools that NREL is developing which can help integrate dynamic DERS configurations into grid scale forecasting and grid scale forecasting models, utilizing things like based diffusion models and adoption curves at a very granular level. Those tools are still under development, but they should be dropping just in time, probably for the deployment of FERC 2222 rules, which I'll get to in a second. Hosting capacity, I think, is also a huge area of focus in planning, basically seeing how much distributed resource any given feeder can accommodate before bad things start to happen. And exploring non-wires alternatives in places like California and New York is a good example of how these tools are being utilized. And then lastly, I'd like to mention locational value tools. I think there are a number of enterprise level planning platforms out there that are starting to, that have been traditionally used for sort of centralized supply side planning, but now are being modified to integrate distributed resources on the distribution system. And really those are only limited at this point by the quality and consistency of data that they can get from things like advanced metering infrastructure on the grid as it exists already. On the policy side, as I've mentioned multiple times now, FERC 2222 has really been, or will, it's in the process of still being deployed, but it stands to represent a watershed moment for the proliferation of distributed resources on the grid. And for those not familiar, basically it has mandated that states open up their wholesale markets to all types of distributed resources. It is incumbent on the states now to determine the mechanisms for participation. But basically it says that state regulators, while they can address things like reliability, safety, cost impacts, all of their normal purview, they cannot regulate who participates or how they participate. So that's a major change. And some of the RTOs have already started to preempt this. PJM's capacity market for EE, which has been modified recently, is one that comes to mind. I think MISO also has started limiting aggregations to single pricing nodes to try to ramp up that ability to see that. But again, I want to come back to my initial point, which is that customers are really where the nexus of all of this is going to occur. There are examples of utility-owned distributed resources in places like California and Texas, but the vast majority of these distributed resources are and will continue to be non-utility owned. To facilitate this, I think a lot of utilities are exploring options to finance distributed resources, even sometimes on-bill financing, or using things like PAYS financing or PACE financing. Programs that combine multiple distributed resources, for example, putting them under existing energy efficiency riders or coupling them with existing DR programs. Leveraging municipalities and other institutional customers to be early adopters to build that capacity. And utilizing DERS to address sort of tangential issues like energy poverty, climate goals, and other energy related policy goals. But I think the bottom line here is that retail programs remain crucial, I believe, to the safe, reliable, and cost-effective growth of distributed energy resources. So thank you all for listening to this lightning talk. I will stick around if there are questions or people have comments.